So Python is kicking off 2026 with what feels like a really transformative set of updates.
Oh, absolutely. These aren't just minor changes we're looking at.
Exactly. I mean, if you're trying to track the future of the world's most popular programming language, you know it can feel like a full-time job just keeping up.
It really can be.
And that's sort of our mission for this deep dive, right? To give you the shortcut, the distilled version of where Python is actually heading right now.
Right. We've synthesized a lot of material, mostly centered around a great feature from InfoWorld from January 9th, 2026.
Okay.
And this deep dive is really built around three core pillars that are defining the year. We're talking unprecedented speed, powerful new code generation tools, and a really crucial focus on code integrity and safety.
That's a perfect way to frame it. So we're stepping away from the small incremental updates and looking at things that fundamentally change your workflow and your application's performance. But before we jump straight into 2026, we probably need to acknowledge the groundwork from last year.
Absolutely. 2025 was a huge year for infrastructure. I mean, we saw significant progress on free-threaded Python.
Right.
And those robust new integrations that let developers easily use lower-level languages, like Rust and Zig, right inside their Python apps.
So that basically set the stage. It signaled that Python was getting really serious about high performance.
Exactly. And now, 2026 is delivering the next generation of tooling and optimization to make all that high performance accessible to, well, everyone.
Okay, so let's unpack this. First up, the quest for wicked speed.
Oh, I like that title.
It's a dual approach, right? Speeding up the developer and speeding up the final code execution. We have to start with Astral and their new project, Jeopardy.
The pedigree here is just fascinating. So Jeopardy is developed by Astral, and if you follow the ecosystem, you know they're the team behind it.
And UV, I mean, that's the package management tool that didn't just iterate, it completely redefined speed in that whole category.
It really did. Before OUV, dependency resolution, installing packages, it could sometimes feel like you were waiting on dial-up, especially in really complex projects.
Oh, for sure.
And OUV just solved that. It was unbelievably fast, often finishing in milliseconds, what used to take, milliseconds. It brought serious systems-level speed to what was a major bottleneck in the developer workflow.
So when that same team, Astral, releases a new tool called Spokty, and they say it's going to do for type checking what OVE did for package management.
You stop and you pay attention.
You really do. Because type checking, while it's essential for catching bugs early, especially in big projects, it can be a real source of friction.
A huge delay. If your CI/CD pipeline is running MySci or something similar, that wait time really adds up.
So Avudi is basically promising to just eliminate that delay.
An ultra-fast, modern type checker.
Yeah.
And the good news for you is that it's already stable enough to experiment with. It's in beta right now.
Which means a massive, tangible performance boost right at the very start of the development pipeline.
Letting developers iterate faster, feel less bogged down by that necessary static analysis.
Okay, so that's the developer workflow covered. Now let's pivot to the raw execution speed. And this is where we get into a pretty dramatic story.
It is a great story.
The redemption of the tail call optimization.
Yeah, we have to rewind a little bit here. The whole concept of tail call optimization is just crucial for efficient programming, especially for recursive functions.
Where a function calls itself over and over.
Right. And in languages that support it, this optimization lets the interpreter reuse the existing stack frame instead of creating a new one for every single call.
Which is how you avoid that maximum recursion depth exceeded error. It saves a ton of memory and time.
Precisely. But when this was first rolled out in Python 3.14, the initial results were, they were disappointing.
I remember that. A lot of frustration.
Yeah, due to the dynamic nature of Python, how it manipulates its internal stack, the optimization just failed to deliver that speed up everyone was hoping for.
And it led the developer, Ken Jin, to actually apologize for the failure, which just shows you how high the stakes are for CPython performance.
It shows the human side of all this complex tech.
Yeah.
But the story didn't end there. Jin and the team, they kept at it. And they found a way to properly enable the feature, but they had to be very, very targeted.
And the breakthrough was specific to one platform.
Yes, specifically focused on Windows by 86/64 builds.
Okay, but why? Why just Windows?
Well, by targeting a very specific, highly controlled instruction set and OS environment, they could implement the optimization without hitting all those compatibility and dynamic complexity problems that just plagued the general implementation.
So it was a masterstroke of containment, really.
It was. By narrowing that scope to Windows by 86/64, They achieved what the source calls striking results. It proved the theory was sound, that the speedup was possible.
Even if it's in a contained environment for now, that's still incredibly encouraging.
It is.
So if you look at this whole section, it's this relentless two-pronged attack on performance. You have tools like ability for the developer experience, and then these deep surgical fixes like the tail-calling breakthrough for the core runtime.
The message is crystal clear. The community is pouring immense resources into removing every single perceived performance bottleneck, whether that's in your build process or in the final execution of the code.
And that's a perfect transition to our next big theme, advanced code generation and frameworks. Because if everything is getting faster, you need tools that can actually build those faster, more powerful apps. And the star here is something called PythoC.
PythoC is fascinating. It forces you to sort of reconsider what Python even is. When you hear PythoC, most of us immediately think of Cython.
Right, the classic compiler. Takes Python code, compiled it down to a C extension for a speed boost.
But the source material is very clear here. PythoC is not just another PythonC compiler.
Okay, so what is it then?
It's being positioned as an advanced macro platform for code generation.
A macro platform.
Exactly. It's a fundamental shift in thinking. Instead of Python being the language you execute, it becomes the blueprint language. It's the intelligence system you use to generate the highest performance C code that's tailored specifically for your app's logic.
That sounds like a pretty big paradigm shift. But, developers are comfortable with Cython. It's well established. Why should they consider this? Is it a true generational leap or just, a specialized alternative?
That's a great question. Python is really aiming for a different level of control and complexity.
Okay.
While Cython is focused on integrating C to Python, Python uses Python to drive the generation of the C code itself. Think of it less like a translator and more like a really sophisticated template engine for systems programming.
So it's aiming to generate more optimal C code in specific cases than Cython might.
Yes, particularly in things like high-performance computing or embedded systems, where that absolute last ounce of performance efficiency is just critical.
So you're making Python the master orchestrator of low-level code?
That's it. It fits perfectly with the goal of generating C for apps where maximal speed is the #1 factor.
You use Python's readability and its great tooling to define the logic.
But you execute that logic at C-level speeds. It's really blurring that line between high-level development and systems programming.
And while we're on foundational tools, there's also a major update for the most popular framework out there, Django 6.
Django is still the undisputed heavyweight champion of influential Python web frameworks. When a major version like Django 6 drops, it's a big deal. It signals the continuous evolution of stable, enterprise-grade tooling.
So what should developers be looking out for in Django 6?
Well, the details are always vast with a major release,
Yeah.
but the key takeaway is that it introduces new Django 6-only features.
Right.
And that often means significant refactoring of core components. They'll be focusing on modern web standards, better scalability, maybe improved handling of async operations, and of course, optimized ORM performance.
So the existence of this update really just reinforces that Python isn't only for scripting or data science.
Not at all. It is the rock-solid foundation for massive, high-traffic web applications. And that foundation is constantly being reinforced.
Okay, so we've covered speed in development, speed in execution, and tools for building faster apps. But if Python is moving into these more serious enterprise spaces, speed isn't everything.
Not by a long shot.
Which brings us to our final section, the specialized tools and discussions around quality, safety, and source integrity.
And this is where the maturity of the ecosystem really starts to shine. We can start with a very specialized tool called PyThoC. It deals with the abstract syntax tree, the AST.
Right, for anyone who isn't familiar, the AST is basically the structural blueprint of your code. It's what's left after you strip away things like comments and white space.
And when a tool needs to automatically modify your code, like adding a type annotation, it almost always works on that AST.
And that's where the problems usually start.
That's where the problem is. Historically, when these automated tools manipulate the AST and then regenerate the source file, they can just destroy all the subtle, human-readable parts of your original code. They'll flatten your indentation, strip out your comments.
I know I've spent an entire morning re-indenting code and putting comments back after some helpful automated script ran. It's infuriating. It makes the code so much harder to read and maintain later on.
That is the exact pain point that PS solves. It's a very clever package that performs these transformations on the AST, but its genius is that it preserves that critical source formatting.
So it keeps your comments.
It keeps your comments intact. It even preserves tricky things like line breaks inside parentheses, which people often use for visual grouping in long function calls.
That's huge. So it lets large teams and automated tools modernize huge code bases without destroying all the historical context and human effort that's embedded in that formatting.
Precisely. The source note's a really crucial application, using PST to seamlessly add type annotations to older style type comments.
Which is vital for modernizing old code to take advantage of all these new speed features.
Without losing that source integrity, it is a tool built for maintainability, for professional longevity.
And moving from maintainability to security, the other critical conversation happening is about the challenge of sandboxing untrusted code.
A very, very relevant discussion, especially now with large language models and these incredibly complex supply chains where you might be executing code from who knows where.
And Python's inherent dynamism, the very thing that makes it so flexible, with exec and eval.
That's also its security Achilles heel when you need hard, complete isolation.
It's the core challenge.
It is. The developer Mohamed Diallo has been central to this discussion, focusing on practical ways the Python interpreters themselves could be made easier to isolate.
So the difficulty is making sure that external code can't break out of its little box.
Can't access the file system, can't import malicious modules. You essentially have to, neuter the interpreter's dynamic capabilities, but only in that specific context.
So they're not looking for a quick patch. This is about fundamentally changing the interpreter's behavior when it's put in a security context.
They are. And if Python is going to continue its trajectory into massive enterprise and platform use, especially AI hosting, these security discussions are non-negotiable.
You can't run a global platform with millions of external scripts if you can't guarantee sandboxing.
Absolutely not. So the focus is on providing robust, easily deployable isolation that ensures safety and trust.
So if we connect all these threads, this pursuit of raw performance, from writability to tail calls, it has to be balanced by this focus on robustness and clarity.
Precisely. These high-level tools like PythoC, which maintains clarity, and these difficult sandboxing discussions, which maintain security. They are the essential ingredients for Python's transition into a truly professional enterprise-grade systems language.
It shows the community is mature enough to worry about quality and safety just as much as pure speed.
I think that's a perfect summary.
So as we wrap this deep dive up, what does this all mean for you? Whether you're a developer or just a technical observer. 2026 is being defined by these unprecedented systemic gains.
Yeah.
We're seeing performance leaps from tools like the ALE type checker and those very specific interpreter optimizations. We're seeing a paradigm shift in how we build apps with PythoC, making Python the intelligence that orchestrates C-level execution.
And critically, all the necessary foundational work is being done to support that growth. Prioritizing code safety through those intense sandboxing discussions and focusing on long-term maintainability with smart tools like PSS.
The implication seems to be that Python is systematically moving into domains that used to be reserved for systems languages.
It's building directly on that foundation from the previous year with the Rust and Zig integrations. It's no longer just the scripting glue.
It's becoming the high-level brain for serious low-level execution.
Exactly. And that leads us to a final provocative thought for you to consider. Since Python effectively lets Python function as an advanced macro platform for generating C code, what happens to the concept of language boundaries? If Python is just a blueprint engine for C, does that traditional line between high-level and low-level development blur even further? What radical new types of high-performance systems-level applications become viable now that Python has so definitively embraced performance engineering?
That's something to keep an eye on, from embedded systems all the way up to massive data centers.
It really is.